Creatine anhydrous is hiding in products you have probably already used without knowing it. The form is less commonly named on front-of-pack labels than monohydrate, but it appears frequently in ingredient lists of products that want to claim higher creatine content per gram without changing the molecule's mechanism of action. The distinction is purely about hydration state. Creatine monohydrate has one water molecule chemically associated with the creatine molecule. The molecular weight is therefore the creatine molecule, 131 grams per mole, plus the water molecule at 18 grams per mole, totaling 149 grams per mole. Creatine anhydrous is the same creatine molecule without the water, giving it a molecular weight of 131 grams per mole. The practical consequence: creatine anhydrous contains 100% creatine by molecular weight, while creatine monohydrate contains approximately 88% creatine by molecular weight. Per gram of product, anhydrous delivers more actual creatine. A 5-gram serving of anhydrous delivers approximately 5 grams of creatine. A 5-gram serving of monohydrate delivers approximately 4.4 grams. This difference allows product labeling to claim higher creatine delivery per gram. A product using anhydrous can state 5 grams of creatine per scoop from a 5-gram serving, while an equivalent monohydrate product providing the same 5-gram scoop delivers 4.4 grams. The distinction matters if you are comparing products on creatine content alone without adjusting for the form. Once consumed, anhydrous and monohydrate creatine are functionally identical. The anhydrous form rapidly associates with water in the gastrointestinal tract, becoming indistinguishable from monohydrate-derived creatine at the point of intestinal absorption. Muscle loading outcomes, phosphocreatine saturation levels, and performance improvements are equivalent between the two forms at equal actual creatine doses. There is no clinical evidence that the anhydrous form produces any measurable advantage over monohydrate in muscle creatine loading, exercise performance, or safety. The form exists primarily as a labeling tool and a way for manufacturers to claim maximum creatine per gram on nutrition facts panels. If you encounter creatine anhydrous in a product, the appropriate adjustment is to dose it equivalently to monohydrate in terms of actual creatine delivered, not total product weight. 3 grams of creatine anhydrous equals approximately 3 grams of creatine. 3 grams of creatine monohydrate equals approximately 2.6 grams of creatine. If the research protocol used 3 grams of actual creatine, 3 grams of anhydrous gets you there. 3 grams of monohydrate gets you slightly short. The pricing of anhydrous products is variable. Because it offers a labeling advantage without any bioavailability premium, some manufacturers charge a marginal premium. Others treat it as equivalent to monohydrate from a cost perspective. The premium is not supported by evidence of performance benefit. For consumers, understanding that anhydrous and monohydrate are the same molecule in different hydration states removes any mystique from the form. The deciding factor remains creatine dose delivered and manufacturing purity, not which hydration state the creatine molecule is in when it leaves the factory. The water molecule in creatine monohydrate is worth understanding mechanistically. In the crystal lattice of creatine monohydrate, one water molecule is incorporated per creatine molecule in a defined position. This is what makes monohydrate a distinct crystal form rather than just moist creatine. The water is not loosely held surface moisture. It is part of the crystal structure and contributes to the crystal's physical properties, including its stability and its dissolution behavior. When monohydrate dissolves in water, the crystal lattice breaks down. The water molecule associated with each creatine dissociates, and free creatine enters solution. The resulting dissolved creatine is chemically identical to the dissolved creatine from anhydrous. The water molecule that was part of the crystal does not contribute anything to the creatine's biological activity. It was a structural component of the solid form, not a functional component of the dissolved active molecule. The anhydrous form's main value is as a labeling tool in markets where creatine content per gram matters for regulatory or competitive reasons. For the end consumer, understanding that anhydrous and monohydrate deliver identical creatine once dissolved removes any reason to pay a premium for the form distinction. Your muscles receive the same phosphocreatine buffer regardless of whether the creatine arrived as a monohydrate crystal or an anhydrous one.